Hey guys, this is the second section, and we're going to talk about areas of trapezoids, rhombi, I guess, and kites. So we're just going to break it down by shape, give you a couple examples, and then we should be good. So first, we're going to start with trapezoids. So hopefully you guys remember what a trapezoid looks like. Just remember that there's two bases and then the two legs. The bases are the parallel sides and then the legs are the opposite ones. And then in here we also are going to need our height, which just like our triangle and our parallelogram is from one base to the other. So it's going to be the perpendicular line from one base to the other. Okay? Basically, there is only one formula that you want to use. It's very similar to area of a triangle, except in an area of a triangle where you have 1/2 base times height. Now we have two bases, so we have to add those bases together. So it's 1/2 the height, and then times base 1 plus base 2. So however you think would be easiest to remember that. It's like area of a triangle, but you add the bases. Okay? So if we're going to use this, here's one very basic example. I give you quite a bit of information here. I give you the two lengths of the bases, 20 inches and 36 inches. I give you this side on the left, which is 30 inches, and then I give you the perpendicular side, which is actually our height as well, which is 18 inches. So because that side on the right is perpendicular to both the bases, then this has to be the height. Okay? And so if we plug everything we know into our formula, we basically know that it's going to be 1/2 times 18, because 18 is the height, and then in parentheses we add our bases, so 36 plus 20. So really the 30 is of no use to us, except for the fact if we asked you to find perimeter, you would add up all those exterior sides. Okay, so they might give you extra information, you just have to be careful not to use things that won't go into your formula. Okay, and of course we would simplify, so do your order of operations, so parentheses and then exponents. So we add 36 and 20, and then we can start to multiply. And when we do that, we get 504 inches squared. Here's another one. This one is a good example to go through because they don't give you anything about the height. So I drew that dotted line in there. It may or may not be drawn for you, so keep in mind you might have to draw a line to find the height. And in this case, they give you an angle measure, and this angle measure is going to be useful to help you find the height. So what we're going to do is find our height first. So if you keep in mind that this is a 30, 60, 90 triangle, so there's multiple ways to solve for the height. You could use your special right triangle rules if you remember those. Those are always really short. You could also use trig, okay, which is what I'm going to do here. So I'm going to use trig by using the tangent of the angle because h is the opposite, and I get the 2 because this little portion is only 2 of the 7, because we know from this dotted line to the right is 5 centimeters, so I just took 7 minus 5, and I got that this length right here was 2. So I have tangent of 60 equals h over 2, and of course we want to multiply both sides by 2, and that gets us that h is 3.5 centimeters. Okay, so we know h is 3.5, and then we already know our bases are 5 centimeters and 7 centimeters, so we would just plug those into our formula, which I did right here. Okay, so we've got 3.5, and then 5 plus 7, and then times half. So 5 plus 7 is 12, and then we can multiply, and we get 20.8 centimeters squared. And just keep in mind to round at the end. Don't round at the beginning because it makes your answer inaccurate. So use as many decimal places as you can, or your calculator at the very beginning, and then round at the end. Alright, now the area of a rhombus or kite are going to be very similar, but there's a couple things you want to make sure you keep in mind. A rhombus has 4 equal sides. You guys should know these from the chapter 6, I believe. And it has diagonals that bisect each other. Okay, so this is important. And those diagonals, not only do they split each other in half, but they're also going to create 90-degree angles. A kite does not have all sides that are equal. What's key here is that adjacent sides are congruent, so the sides that are next to each other. Okay, just picture a kite that you would fly out in the outdoors. Okay, it's not going to necessarily have all sides equal all the time. Okay, It has no parallel sides because they cross each other. And then also the diagonals, just like the rhombus, are going to be perpendicular. So these are just some basic rules that you want to keep in mind. Now, even though they have all these differences, the area is going to be the same exact formula. Okay, so the area is half of the first diagonal times the second diagonal. So in this case, we're not dealing with any bases, right? So we're going to go ahead and look at an example. So here is a kite. You can tell, well, first off, it looks like a kite, but hopefully you guys will notice that we have adjacent sides that are parallel or that are congruent, okay? And we have perpendicular diagonals. So we have multiple pieces of information here. They actually give you each part of the diagonal, which is going to help us in our formula. So we know area is 1/2 diagonal 1 times diagonal 2. Well, diagonal 1 is the 3 plus 3. Okay, so I'm just adding this whole diagonal up. And then diagonal 2 is this long diagonal, and that's 5 plus 4. So that gets us 9. So I just plugged in the 6 and the 9, multiply that all together, and we get 27 meters squared. Okay, so usually a kite is going to be pretty easy, as well as a rhombus, in terms of plugging everything in. Here's an example of a rhombus. Okay, notice here in a rhombus we have all 4 sides that are equal, so this is how we can tell it's not a kite. Okay, using our formula, we have that diagonal 1 is 24. Okay, this is the long side here, where it's 12 plus 12. But notice that they don't give us anything for the second diagonal, and they only draw part of it. So keep in mind, you can't forget the second half. But in order to find out what this is, we're going to have to do some Pythagorean theorem. So I just called it B, and we're going to do Pythagorean theorem. So a squared plus b squared equals c squared. In this case, the 15 is the hypotenuse, so that's our c. And so we plug in 12 squared plus b squared equals 15 squared. And we start to solve. So this is also something you guys should be capable of solving. We can simplify, so 144 plus b squared equals 225. Of course, you want to subtract 144 to the other side, and we get b squared equals 81, and then take the square root of both sides, so we get b is equal to 9. But keep in mind, b is only half of the diagonal. This was just this portion that was originally drawn. So if 9 is half of it, well, that makes the whole diagonal 18. And now, after using Pythagorean theorem, we can go ahead and start plugging into our formula. So we get half of 24 times 18, which is going to get us 216 meters squared. So please keep in mind that you want to make sure you have everything you need. You might have to do a little bit of work to get what you need, but just make sure that you show that in all your steps. Don't do all of it in your head, because I want to know where you get your numbers. Okay? And that should be it for this section. So it's very simplistic as long as you know the formulas to plug in. Yes, you might have to use some trig. Yes, you might have to use some Pythagorean theorem. Just make sure that you're thinking step by step of what you need and how you might get it, and this section shouldn't be too bad. Okay? If you have any questions, let me know. Otherwise, go ahead and get started on your packet.